With negative exponents today. So we've worked with exponents quite a bit, just not when there is a negative one. Now, the way we have been doing our exponent rules is using a as a base. So again, that's slightly different. The exponent rules handout I just gave you uses x. Same idea. We've got some base raised to an exponent. So there's a pattern for these. If the exponent is negative, it actually means that this is a very, very tiny number. Normally when we do an exponent, our numbers get much bigger. The pattern for this is always the same. It's going to become a fraction with 1 as a numerator. Every single time, a fraction with 1 as its numerator. And the denominator is just the same base raised to the same power, except now that n, that exponent, is positive. So this is the rule for how to work with negative exponents. Let me show you an example. If you just had a number as a base, for example, 10 to the negative 3. We just follow the pattern. It's going to be 1 over, and then we say the same base, and the exponent becomes positive. If you have just a number, not a variable, but a number, I want you to simplify this. Don't leave it as 10 to the power of 3. Now, there's a shortcut. If the base is 10, does anybody remember the shortcut? Rather than doing 10 times 10 times 10. Anybody remember the shortcut if the base is 10?
Just add the number of zeros.
Good. The exponent is the number of zeros. So there should be 3 zeros. That's only when the base is 10. But if it is, that's a nice shortcut. Otherwise, 10 times 10 times 10. Make sure you don't do 10 times 3. It's not 30. So this is the equivalent of 10 to the negative 3. 10 to the power of negative 3. So notice this is a tiny fraction. 1 over 1,000, 1,000ths. Okay? So let's just try one more that looks like that, and then we'll switch it up a little. What if I had, let's see, get a new color here. 16 to the negative 1. 1 over 16 to the positive 1. What's 16 to the power of 1, Diego? Just 16. 1/16 would be your answer. So, that's the basics of this. Now, in your book, by the way, I'm just going to show this real quick, on where we're working, there is a summary of all these other exponent rules that we've already used. Here they use A's and B's as the base numbers. It's the same thing I gave you on the handout. It's just one extra place you can look in the book. So let me show you an example of a problem that does a little bit more. We're going to be using most of the exponent rules on that handout. You might not see all of them. So for example, b to the negative 1 raised to the negative 3. What I want you to do is to think, is there another exponent rule I could use first? Because let me just show you how this would get complicated. You don't need to write this down because this is not how I want you to solve it. If you first use the negative exponent rule, the first thing we would do is take this. So again, you don't need to write this down. We'd put 1 over b to the positive 1, which is just over b. And then this is to the negative third, right? See, so I just simplified the inside, and I still have this negative, and then I'd go 1 over b to the, it gets really confusing if you do this. You can do it this way, but it's harder. So, rather than starting with the negative exponent part, when you see more than just this, right? If it's just this and you're just simplifying, you just use the negative exponent rule. If you see more going on, what I want you to do is think, what other exponent rules can I apply? So either looking in your book, looking at the handout I gave you, or just remembering. When I have an exponent inside and outside the parentheses, what do I do with them? Pammy?
Multiply.
You multiply. Negative 1 times negative 3. Oh, I don't even have negatives anymore. And since I don't know what b is, I'm done. Look at that compared to what I had started over here and crossed out. On this, I wasn't even done yet. I had 1 over b, and that thing was cubed, and I'm going to have to simplify all that. That you can do if you want to challenge yourself, but I would just do this. Izzy?
So you just simplified
the rule of this, and again, this is on that exponent rules worksheet handout that I just gave you, and it's also in your notes from a while back. When there's an exponent inside and outside the parentheses, they multiply. So you just, whatever the numbers are, use the rules of multiplying. Negative times negative makes it a positive. And now we don't have to even worry about the negative exponent rule. Let me show you another one. 3x to the negative 1 whole thing squared. So again, before you start with the negative, first look to see what other exponent rules could I apply. In this case, I have something raised in parentheses to an exponent. Remember that means that everything inside gets raised to the power of 2. So if I rewrite that, that's 3 to the power of 2 times, because it's all pushed together, I'm just kind of separating it out here, times, now, x to the negative 1. X was the only thing to the negative 1, not the 3. The 3 was just multiplied by the x. This piece is also being raised to the power of 2. So all I'm going to do is apply the rule that everything inside the parentheses gets raised to the power of 2. On the handout I gave you, again, this exponent rules sheet, that would be this one, where it shows, hey, everything in the parentheses got raised to the exponents. So I want you to look at all the other exponent rules before you start with the negative one, if it has all this stuff going on. Let's start to simplify. 3 squared, that's simple. 9, at least I hope it is. Now, inside and outside the parentheses. Again, this was just like the last one, and again, I'll show you here. Inside and outside the parentheses, it shows them being multiplied. So that was kind of like this one that we did here with the b's. Inside and outside, negative times positive makes a negative. So negative 1 times 2 is negative 2. So again, we're going to look at all the other exponent rules first. Simplify as much as you can. Now there's nothing else I can do except deal with this negative 2. A negative exponent is not considered simplified. It'd be like an improper fraction. We got to deal with it. We don't want it to be negative. Now, the 9 is not raised to the exponent, just the x. So the 9, I'm just going to keep it with the 9 times to show it's not part of that negative exponent. X over negative 2. Let's apply the rule for negative exponents. 1 over, same base, same exponent, but it becomes positive. Last step, let's just put this all together. It's 9 times. Well, 9 is my numerator, so 9 times 1 is 9. We could put it over 1 if that helps. You can do that. 1 times x squared is just x squared. Here is my answer. So again, starting to apply any other exponent rules first and deal with the negative exponent at the end. Just one final example and then we're done for today. Last example. 7 to the negative 2 times 7 over 7 to the negative 1. I'm just trying to show you some of the different exponent rules as a reminder. I'll start with my numerator. I am multiplying the same base. I actually see 2 bases. That, again, is number 1 on this list. If I multiply the same base, I add the exponents. So on the numerator here, let's add our exponents. The base stays the same. What's my exponent on this second 7 here? Okay, I see some 1 fingers held up. So if I multiply the same base, I add the exponents. Negative 2 plus 1 is negative 1. Now we could apply the negative exponent rules to the numerator and the denominator, and then we have a fraction in our numerator and a fraction in our denominator, but we don't need to do that. Anytime the numerator and the denominator are the same, what does it equal? 1, done. 1 and done. The numerator and the denominators are the same. It's like 5 over 5 or 10 over 10. It equals 1. Doesn't matter what it is. If they're the same, it equals 1. Now, one more reminder. I'm not going to do another problem, but just a quick reminder, or we'll do just one quick one here. Let's do one more. Sorry, I lied. One more. This one's quick, though. I just wanted to remind you of one more exponent rule. 5 over 5 to the negative 3. We, again, on this numerator, we don't have the invisible 1 exponent, we can add it. Your handout shows division with the little fraction bar, but this is division. When we divide the same base, we subtract the exponents. 1 minus negative 3. All right, I'm subtracting the exponents. I write down my invisible 1. 1 minus negative 3. If I add the opposite, no more negatives. Now 5 to the power of 4. If you just have a number, I do want you to multiply it out and to get me a final answer. 5 times 5 times 5 times 5, you can use your calculator, 625. So again, if you divide the same base, you subtract the exponents, and just make sure your subtraction is different than your negative. That's it. Just practicing with negative exponents today.